Ladies and gentlemen, moving on to our next technical session, processing high-performance plastics with Horst-Werner. As I invite our gentlemen to join us for this, ladies and gentlemen, I'm hoping you're going to keep up the energy. Please join me in welcoming Mr. Horst-Werner, Head of Technical Consulting and Sales at GÜNTHER. Ladies and gentlemen, we are so thrilled that he's here with us for this session. Over to you.
So this is front, this is back. The green is front and the red is back.
The laser is over there.
No, this red is back.
And the laser pointing?
Laser pointing is the center one. I don't know if it's working though.
Hello everybody, I hope you're fine. Today I will talk about the triangle relation of molders, mold makers and hot runner suppliers. Triangle relations are not easy, as most of you know. And especially in the hot runner business, I am on the way since more than 25 years, and perhaps I can give you some ideas to make the life easier. Yeah, my name is Horst-Werner Bremmer and I'm coming from Germany directly. I'm living close to the headquarters, and you see here some pictures of the old company which Mr. Günther founded in 1983. And up to now, in 2025, we have more than 40 years experience in producing hot runner systems for engineering plastics. And we have a lot of fun in doing this. All what we are doing, you are in the center of that, what we are doing. You wear the crown. And we want to have a relation, a partnership, and not one is sitting on the top and we are on the down. We have to work together that the boat is going in the right way. We deliver to you technical support from the application department, designings. We have an online configuration system where you can get in 10 minutes complete 3D data for your mold, depending on the application. We give seminars to you. We are on exhibitions. You are very welcome to visit our booth at the K Show in October and also to visit our booth outside. Then we can show you some samples. And if you have questions after my presentation, I have a lot of time for you. I will be here until next week, Thursday. We are located in Frankenberg-Eder. Frankenberg-Eder is for some people the center of the world. I want to say also for me, you know, Frankenberg-Eder, 10,000 people are living there, and for them it's the center of the world compared to the other places. We make approx 80 to 85% of our business in Europe, and we are expanding because we have a transformation of mold making in Europe. I'm not happy about this, but more and more molds are coming from China and giving us really pressure. And we have to find good solutions to supply to Chinese mold makers, for example, also to Indian mold makers, that the molders all over the world who are using Günther, that they are happy with their molds. Yeah, we have 3 USP, which I want to present to you today. This is one, the 2-part shaft, the PM needle guide, and the blue flow heating element. We have approx 200 people in Frankenberg working and producing hot runner systems for engineering plastics, and we have a lot of experience. You see on the left side an open system with a nozzle with tip, and on the right side a nozzle with a needle guide. When I started at Günther in 2003, we had approx 8% of the systems delivered with shut-off systems. Meanwhile, we have approx 38%. And Mr. Günther asked me last year, Mr. Bremmer, what do you think? How many cavities in the world are gated with shut-off systems? I said, Mr. Günther, it would be similar than we deliver, approx 35%. Mr. Bremmer, we have chances to sell a lot of more. It's approx 68% of the hot runner gates are done with shut-off systems. 68%. And then I thought about this in the fields of technology, medical part, cascade injection, bigger parts, family molds. These are all technologies where you need shut-off systems. I have 2 examples to show our benefits for you. On one side you see an open system for the processing of PPS. On the other side you see a 16-drop system, wavegate for medical parts. This three-top system was in Switzerland producing, and the customer had problems with the three-plate mold, with not filled parts, a bad surface, big pressure loss, and then we changed it to an open system with direct gating. Before we had approx 30% bad parts, and after the change of the mold, we were below than 1%. For this, we used a nozzle with a two-part shaft. I think the laser is not really working, so I try to explain it with words. We have inside the material channel with a screwed-in tip. Around the material tube we have an heating element, in this case a blue flow heating element, and between the blue flow heating element and the two-part shaft we have an air gap. As you know, air is the best insulation, and we can get a real good thermal separation between the hot melt and the cold mold in a small area. If you compare this to other systems, I know that a lot of mold master systems, UDE systems, Synventive systems are running in India. They use mostly the way on the left side, a small sealing area, very sensitive, and mostly after 2 or 3 disassemblings, it breaks and you get a leakage. If you use a GÜNTHER system, you see on the right side a two-part shaft where we have in the front a titanium alloy, and the heat mainly is going to the tip, and the contact area of the mold is on the right side, and we have a height of approx 10 to 12 millimeters sealing area. So very robust. If you change inserts and assemble them back, there is no risk to damage the sealing, and so we get a high leakage safety. Also, the benefit is in the temperature situation close to the gating point. You see here that we have a difference of approx 20 degrees centigrade. And when I'm talking about direct gating of plastic parts, the smallest direct gated part of us is 0.004 grams. I have it here in this small box, and I have special glasses for you that you can have a look after this on the gate point quality. Here a small movie for explanation, and I hope it runs. We take a two-part shaft nozzle, type 5 SHF. Perhaps you can make the music a little bit down. The music is down, yes, thank you very much. And we cut this nozzle. You see the blue flow heating element, which produced in our own house, the air insulation, the two-part shaft, and then we make a cut through the material tube. And with the first filling, we get also an insulation cup around it to support the thermal separation. Then we have the material flow in the center, and you see here in the comparison directly the heat flow to the mold, which has the result that the other suppliers have to bring more heat from the back and get heat peaks in the run, in the melt run. Yeah, the second USP is a heating element. This is a standard heater. We press the heater in a brass body, and the heater itself has a linear heat distribution. And if you want to effect a better heat situation in the front of the nozzle, we have to make more turnarounds, as you can see here. There we have some restrictions regarding place because of the thermocouple, which is placed close to the gating point area. In this comparison, you see directly the difference of an heater, blue flow in blue, and a standard heater. We can concentrate much more energy in the front area. It's physically based on the situation that we have the diameter of the heater, a specific resistance, and the length of the heater, and then we create a resistance area. And where we have high resistances, we give a lot of energy to the material tube. Where we have a low resistance, we give less energy to this area. These are the production steps for the blue flow heating element, which can process plastics up to 450 degrees centigrade. Here you see the heat distribution. We have approx 50% close to the tip, 25% in the head area, and in the middle for connection. Also, the temperature we bring on the melt is more homogeneous, and we don't have so many heat peaks on the plastic itself. That's we can process sensitive plastics. Sometimes also plastics with color badges are sensitive. And the result, here you see a temperature profile of a competitor nozzle. These temperature profiles are measured in assembled conditions in the mold. The nozzle is filled with plastic and an external thermocouple is going from one side to the others. And this competitor has a delta T of 85 degrees centigrade. And you see at the controller only one temperature, not the reality. This is the reality in the melt tube of a nozzle. Compared to a GÜNTHER nozzle with blue flow technology, you see quite a difference. We have here a temperature delta T of 35 degrees. We produce these heating elements in clean room production in our house. And a small video to show how we produce it. Here you see a GÜNTHER nozzle. We can equip them with a standard heating element, the heater pressed in a brass body, or we can equip it with a blue flow heating element, which reduces the sizes of the nozzle, which reduces the energy consumption, which increases the running time. Here you see once again a heater, a standard heater, and a blue flow heater. To develop the blue flow heating element, Mr. GÜNTHER took approx 12 years. He started in 1998, and official introduction was on the K Show in 2010. At this point, we had approx 4,000 nozzles running at the customer. The heater itself is so thin, we cannot simulate this with Sigmasoft or any other solutions. We have to create them, to build them, then we have to measure, have to change, and then see, is this now okay? And it is approx 2 to 3 times before we have then the right creation. And you see here the screens for the different kind of nozzles we have. We do this with screen printing in the clean room. This is a negative cutout for the blue flow heating element. And then we clean the steel tube, bring on this steel tube an insulation layer in blue color. And then on the screen printer, we print on the heater layer with the dimensions. And finally, it goes to an oven and we burn out the ceramic at the temperature of 850 degrees centigrade. This is also a patented USP from us for you. Here you see the different layers in small situation. Who of you knows these kind of heaters? Make only this. Oh, my colleague knows it, okay. So it's perhaps interesting for you. Okay, I will use the time for some examples afterwards. And the last USP for you is our PM needle guide. This needle guide is made of polymetallurgical steel and has a hardness of 60 HRC. Normally you use inserts with a hardness of 52 HRC. And if you get wear, you have to weld them. Or you have to open it, you have to use another needle diameter and step by step. And then you come to a point you cannot open it more and then you have to weld it. Our needle guide can be changed very easy. And also because of the hardness, we get a long running time. This small video shows the function, and I will say some words about this. We go the same way we cut the nozzle. It's a modular structure we have in our system. Similar components are used for different type of nozzles. And here we cut it off, and then we show you the function of the needle guiding element. We have cylindrical sealing in the front with a height of 0.3 mm. And the needle guide, or the needle is guided over the side of it. We have 4 different versions. And here we open it, type LA. The smelt is coming through and the needle is guided over the side. So the needle front has not a direct contact to the guiding element before it comes to the sealing area. And the needle itself is made of an HSS steel with a hardness of 64 HRC, and it's coated. It's not an easy injector pin like Manner is doing this or like Moldmaster is doing this. Yeah. And for fast running molds, we use needle guide type KA. Fast running molds mean 3-second cycle time and less. Then we have the guiding in the material tube itself. Here, a summary of the versions we have. And here you can see that we can disassemble this needle guided element when the mold is completely assembled. So you have a very fast reaction time in changing the needle guide. Here the production drawing of it with the dimensions, and we developed together with the company Studer from Switzerland special kind of grinding machines where we can do the inside grinding and the outside grinding of depending geometries in one fixation. Yeah. The final structure of the gating point is then produced on special microcut machines from Switzerland, where we have a wire. On this wire are diamonds. The wire is fixed on the top and the bottom, and we go this way and go around this way, and so we can guarantee you the dimensions and the tolerances. Here we do the sealing then in the manifold. We have a special system with grooves that we get a leakage safety for the melt. We have different kind of movements. Single wave gate is an easy system, and we can deliver up to 64 or 128 in combination. We do simulations with SigmaSoft. Here an example that we guarantee temperature for the manifold of plus minus 7 degrees centigrade. With the SigmaSoft solution, we improved the temperature situation. As you can see, the first step, we wanted to go with one circuit, and then we changed to 2 circuits and special pressure pads, and we get a very good temperature profile. We do this on 5-axis assembly machines, and I want to welcome you really to our company. If you are in Germany, visit us. We are 1 hour 15 away from Frankfurt Airport, so it's not so far for you. We have an application technical center where we can make tests for materials and can test molds, new technologies. And here are some applications from last year. We realized this is a 16 plus 4 drop system. We created a waste cavity because we wanted to reduce the residence time of the material in the hot runner itself. You see here the pink one is the waste cavity, and the blue one is what the customer needed at the part. Here we have direct gating on a small circle diameter of 19 mm for a packaging part, completely shut-off system. Here we have a 2-component mold, a combination of PP and TP on a very small area. As you can see here, we have to place it, the manifold concept with main manifolds and 2 sub-manifolds seated. These are the parts itself. Or here for the packaging industry, we are gating inside the part with 2 tips. This is a concept for the manifold. Here an interesting application from the medical field we delivered to Switzerland. It was a POM part. We used for this stroke unit lifting plate, as you can see here. And this is the part itself. And we guide our customers with the first start, with training, with seminars. You switched off the sound? It doesn't matter. Okay. Only a Switzerland voice. The interesting, I go back one time, and the interesting is for you here the sound of a Switzerland guy. This one.
Kann ich sie am Roman von gestern noch schicken und am Falk, die Interessierten sind.
This is similar to India when you have your dialect. and you talk to me in your dialect, and I will not understand it. Similar if a Switzerland guy talks to a German guy, you also don't understand him. From the application field, an 48-drop system, completely electrical driven stroke unit for wavegate system. And finally, one side gating part for the medical field. Also interesting for you. And I want to say that this is officially the first official introduction of GÜNTHER Fibro together. Fibro and GÜNTHER want to make it strong here in India and want to give you the best solution for your molds. Thank you very much for your attention. All the best to you.
Thank you so much, sir, for that incredible presentation and for taking us through it. May I please request you to join us center stage? May I please request Mr. Sachin Netrabal, EC member, to please join us on stage and hand over a token of appreciation. We are glad that you have taken time out and are here for the 9th edition. We appreciate that you've come here for this wonderful presentation. Ladies and gentlemen, please join me in thanking him for this.